let's get started with Andy and the sky this month.
Okay, am I on here? Hello, my name's Andy Beaton. I'm speaking to you from my basement office in downtown Toronto, which I share with many spiders and centipedes, and I'm here to talk about the sky this month. I have a usual list. People who have seen me speak before will recognize it. The big picture, key dates, the moon, planets, some deep sky stuff, a double star, obviously variable stars because it's me, and whatever's coming up in the world of spaceflight over the next month. So starting with the big picture, this is what the sky is looking like tonight around 10:30 in the Toronto area, looking west. Our spring constellations are disappearing. Leo is setting, followed by Virgo and Bootes. Um, What I do note is we've got very little in the way of planets visible. There's a couple of minor planets there, Makemake and Haumea, but very little in the way of the fun planets that we all like to look at. By the time we get around to the next meeting, the morning before, on August 7th, this is just before sunrise, and now we do have some planets. If you're in a planetary mood, getting up early in early August is probably your best option between now and the next meeting. And by then, we're actually starting to see the fall and uh, heaven save us, the winter constellation is starting to show up. You see Orion peeking up just before dawn. So what do we have coming up over the next month? Our key dates, we've got not one but two new moons, July 5th and August 4th. The moon will be at apogee on July 12th and perigee on the 24th. And what this means is it will be closer or farther, and you can actually take pictures and see that the size of the moon differs from those two dates. You put them side by side, have a little observing project. Earth is at aphelion on July 5th. That is the point where the Earth is the furthest from the Sun, which explains why it's so hot in summer. It doesn't, I'm making a joke, obviously, but the elliptical orbit doesn't really have a big effect on our weather. But if you're interested, yeah, you could take a picture of the Sun now and take a picture of the Sun again in 6 months and compare the sizes as it appears from the Earth. It'll be a much smaller difference than the moon, but it is there. July 21st, we have a new moon, or sorry, a full moon, and the South Delta Aquarian meteor shower following on July 28th. That's actually a bit disappointing. It's coming a bit too close to the full moon for us to really get the dark skies that we like in the morning, but at least we get a meteor shower. The nights are getting longer again. We're past the summer solstice. Astronomical Twilight ends around 11:18 tonight and starts again at 2:50 in the morning. Yeah, that's a very short, dark night. Bad news for you astrophotographers. However, by August 6th, it's getting better. 10:18 is when twilight ends, and 3:52 in the morning is when it starts up again. So a significantly longer viewing time. So we've got the moon. Everybody likes to look at the moon, except everybody who likes things in the dark sky. New moon on July 5th, first quarter on the 13th, full moon on the 21st, and last quarter on the 28th, and then a surprise bonus extra new moon. We have the lunar X coming on July 13th. Unfortunately, during daytime for us here in the North America, but if anybody is viewing from the other side of the world, what the lunar X is a pair of craters side by side. When the sun is at illuminating the moon at a certain angle, it makes a neat X thing on appearance of a brightly lit X against the dark shadows of the lower crater. It's a neat thing to see. The lunar straight wall, Rupus Recta, is visible for longer than the lunar X. It's more than a few hours, and it's on the evening of July 15th if you want to go looking for that. So we have planets. Mercury is barely visible in the western sky after sunset. You want a nice low horizon, no trees, no buildings, because it doesn't get very high above the horizon. Even closer to the sun for this month is Venus. It has the virtue of being brighter, but it's going to be a tough thing to find for the next few weeks. Mars, on the other hand, is showing up before sunrise. Um, it is very distant. It's only 5 or 6 arc seconds across. It's very small. You're going to be disappointed if you're looking for features. It's going to be very little visible through the telescopes that any of us have, but at least it's coming back, and we can look forward to better views later in the fall. We have Saturn and Jupiter coming in the morning. Jupiter is rising in the morning, and on August 13th, which is actually not the sky this month, it's the sky next month, there will be a very close pass with Mars within the field of view of an average telescope eyepiece. So look forward to a cool view then. We have an extra interesting thing happening on Jupiter this month. 8 double shadow transits. Now, what a shadow transit is a shadow of one of the moons of Jupiter being cast on its cloud surface. Let's see. Yeah, here's a picture I cooked up in Sky Safari. I don't know how well it's showing up over the screen, but you can see a couple of black dots, hopefully, on the surface of Jupiter. That's kind of what it's going to look like through the telescope. You might even be able to see, with a sufficiently good telescope, you can see some of the moons as they're passing in front of Jupiter as well. We call those satellite transits, and so we're not only getting double shadow transits, where we're getting 2 moon shadows at once. Some of them will actually have the moons as well as the shadows showing up in front of Jupiter. Saturn's rising around midnight, and it stays pretty close to the same spot throughout the month. It's not moving very much. It's at that time of the orbit where the Earth is catching up to it. So as far as we're concerned, it looks like it's sitting still. The rings are sort of open, but they're slowly closing. So get your views of Saturn in as soon as possible, because it won't be long until the rings are edge on, and it'll be a disappointing view. The ice giants, Uranus and Neptune. Uranus is rising around 2:30 in the morning, and it's rising earlier and earlier as the month goes on. Midnight by the next meeting. It's visible throughout the night, or after it rises, and is visible to the naked eye in extremely good skies away from the city. Neptune rises earlier, just after Saturn, and it's visible until sunrise as well. Not nearly as obvious to find. You're going to need binoculars and some kind of direction finding software or maps. I know they're dwarf planets and not planets, but Pluto and Ceres are visible. Pluto is in Capricornus this month. It's getting away from the Milky Way in Sagittarius, so it should be much easier to find than it was a couple of years ago. 14.4 magnitude, you're probably looking like you're going to want an 11-inch telescope or better, or you can do some imaging and try and get images of Pluto a few nights apart so you can see it moving against the background stars. Otherwise, it's very hard to confirm you've seen it visually. Ceres is a much easier dwarf planet to find. It's 7th magnitude and currently passing through the teapot in Sagittarius. That's the asterism in the constellation that looks like a teapot. I always like to throw in something in the deep sky. Since we're looking in Sagittarius for Ceres, we'll stick around that same area for M22, the Great Sagittarius Cluster. And this is what it looks like. It's one of the better globular clusters from the point of view of the Earth. This image from our friends at the Canada-France-Hawaii telescope. It's 5th magnitude, so it is the brightest globular cluster that we can see from around here. The southern hemisphere, they get better ones, but this is pretty good. It's an interesting thing because it's between us and the bulge at the center of the galaxy. So what professional astronomers have been doing is using it to act as a gravity lens to look at objects in the bulge in the center of the Milky Way. So it's a neat thing that we aren't going to do, but interesting to know that other people are doing that. And it's also right in the middle of a whole heap of stuff that we see right around the center of the galaxy. There are other globular clusters there. We're right nearby the Trifid and Lagoon Nebula. And it's just a neat place to set up a telescope and just put in your wide-angle eyepiece and just look at the vast numbers of stars there. It's a very nice tourist spot of the sky. And I've gone for a globular cluster because I think globular clusters are the objects, the only ones that look way better through a telescope to the naked eye than they do in photographs. You don't get the burnout at the center of the object that you do with a photograph. Now, if you're a more advanced observer and you're looking for something more challenging to do with M22, it is one of 4 globular clusters with a planetary nebula. Now, I don't believe it's visible to the eyeball with any telescope any of us can afford, but I'm hoping photographs could capture it. It also contains 22 variable stars, mostly are Lyris types. People from Toronto would know that there's our own Helen Sawyer-Hogg, famous Toronto astronomer, made her career observing RR Lyrae stars in globular clusters, so there's something you could emulate. It also apparently contains 2 black holes, once again, probably not within the ability of any of us to observe it, but just the fact that they're there is kind of interesting. I mean, I tracked down the star that Cygnus X1 is orbiting, and obviously I didn't see the black hole, but just tracking down the object itself, knowing it's there, was pretty fascinating. So we have our usual boatload of comets and meteors. We have the southern Delta Aquariids peaking July 30th, around 20 meteors an hour. Which isn't bad. The phase of the moon is not really in our favor, but we should be able to see something. The Perseids, they're peaking August 12th. Strictly speaking, that's someone else's job to warn you about that because it's next month. But apparently early Perseids can start anytime after July 14th. So if you're out under their dark sky and you see a meteor, trace it back towards the constellation Perseus, and you can decide whether you've seen an actual live Perseid or not. We have a couple of minor meteor showers, the July Pegasids and the Alpha Capricornids. These ones we're looking at less than 5 meteors an hour. I wouldn't go out to look for them explicitly, but if you are out under the night sky and you happen to see a meteor, trace it back, see if it is pointing towards Pegasus or Capricornus, and you might have identified a meteor from one of these minor showers. And we've got even smaller showers than that. We're looking at 1 or 2 meteors per hour. Uh, Same thing, if you happen to see a meteor, try and trace it back. We've got the C Andromedids, the Zeta Cassiopeids, and the Eta Eridanids. All of them fairly long showers with not much activity. So keep an eye out for meteors. Maybe you've seen one of these rare and obscure showers. We have comets. I wonder if anybody's watching from the southern hemisphere tonight. Sometimes we get people coming in, and you folks are the lucky ones. You get comet 12P Pons Brooks, 7.4 magnitude in Puppis. We can't see it from up here. We rely on you to get some good pictures and post them where we can see them. For those of us up here in the northern hemisphere, 13P Olbers, 7.5 magnitude comet in Lynx, and then some smaller ones. C2023A3, I hope I get this right, Chusenshan Atlas in Leo, C2023V4 Kamarasa Dushanovich in Lynx, and 2021 S3 Pan-STARRS in Draco. I don't think any of these are visually spectacular, but it's always interesting to see comets and track them as they move throughout the sky. Now, we also have a lot of aurora happening. Recently, we had a gigantic auroral display not too long ago. I hope everybody got a chance to see it. It's a busy time on the sun. We may get another auroral display sometime in the near future. Obviously, I haven't heard anything about some tonight, but keep an eye at spaceweather.com for maps and up-to-the-date forecasts. And I'm going to share this with you. This is an image of our big aurora display taken right from downtown Toronto. I mean, it's not the spectacular ones that everyone's sharing online, but I wanted to share it because a lot of us live in the city and aren't necessarily aware that on a good night, you can see the aurora from downtown Toronto or whatever big city you happen to live in. So keep an eye out for forecasts for news. Obviously, if there's going to be a big display like the last one, it's going to be all over the internet, so we should all be able to get sufficient warning. In memory of our good friend Blake, who passed on recently and was the guy who got me hooked on viewing variable stars, I've picked a Gamma Delphini. It's the top left star in the lozenge of the constellation Delphinus, the dolphin. 4.4 magnitude and 5.0 magnitude pair. Some sources describe it as yellow, white, and orange. Other sources describe them as orange and lime green. I'm curious to know if people observe it and what colors you perceive. It's always a crapshoot trying to decide what colors these things are when you're relying on human eyes and dark skies. But yeah, I'm curious to see what other people say. They're about 8.8 arc seconds apart, so you're going to need a telescope to split it. And there's an orbital period of just over 3,000 years, so this is one where I wouldn't bother trying to track changes from night to night or even year to year. I don't think we are going to see much of a change in any of our lifespans. I can't go through one of these without a variable star. Zed Cardalis is the one I picked this month. It is a cataclysmic variable star of a type called a dwarf nova, related to SS Cygni stars and U Geminorum stars that I've talked about before. It's circumpolar in Canada. We should be able to see it any night where it's clear. and it goes between 9.8 and 14.5 magnitude. So what's happening with this is we have a white dwarf and a giant star, and the white dwarf is slurping material out of the upper atmosphere of the loosely bound giant. The material spirals in through an accretion disk, and what's happening with these ones is, rather than a classical nova where material accumulates on the surface of the dwarf, in this case, material is igniting and fusing in the accretion disk, which leads to weird effects. This one's unlike the SS Cygni and UGEM norm stars in that the brightness can stall for a few months halfway between the maximum and the minimum. I'm not sure the process is entirely understood, so this is one where amateur astronomers can make a contribution to science. Get your observations, send them in to the American Association of Variable Star Observers, and especially try and get those observations in as soon as possible, because what's going to happen is professional astronomers studying these stars are going to see from the AAVSO database that things are happening, and get their telescopes pointing there for some immediate data collection. So yeah, this is one where you and I can contribute actual science. And because it's a fast moving thing, this is something that the automated sky surveys are not going to catch. So this is up to us. I don't know how many people here are old enough to remember when television shows had summer reruns. We get all the new shows through the winter, and in summer it was the same old stuff. Well, here is a variable star that I posted in my talk a few months ago, and we're still waiting. T Corona Borealis has a recurrent nova that last went into outburst 70 years ago, and we've been expecting it, and it hasn't gone off yet. It should be going. They're expecting it sometime before September. It's another one of those things where we've got a giant dumping material, this time onto the surface of a dwarf, which will build up and go from 10th magnitude to 2nd magnitude, making it one of the brighter stars in the northern hemisphere for a brief time. It hasn't happened yet. At least it hasn't happened when I put this presentation together yesterday. So keep an eye out for it, and you might be the one to spot it. Once again, aavso.org is the place to go for maps and to report the results when you see it. So what's coming up in spaceflight? Obviously, everybody's wondering what the heck is going on with the Boeing Starliner. Are the astronauts really stranded there? Are they just resting while they decide the best method to test the machine before they fly back? Good question. Nobody knows. No one's saying anything. We have the first flight for the Ariane 6 coming up on July 9th. That's the latest of the ESA's rockets. We have a Dragon Polaris Dawn capsule EVA. People are going to be stepping out of one of the Dragon capsules in orbit. They're going to be testing out the fancy new spacesuits. This will be one that'll be fun to watch on TV. Or on the internet, I should say. The ISS is passing over late night and early morning from now until July 30th. Have a look at the ISS now. They're starting to make concrete plans for deorbiting it in a few years. Anyway, heavensabove.com is the place that I go for times and locations. The Event Horizon telescope was the one that I was looking at last time. I'm also going to say, check out what's new from the James Webb telescope. And this is one that I dug up a couple of days ago. This is Jupiter in infrared, image from NASA and ESA and all their partners. The brighter colors are higher, the darker colors are lower. It's a view of Jupiter. I've never seen anything like it before, but it's really cool. I would put this as the desktop on my computer just to admire it. So what if it's cloudy? I always want to wrap up my talk here with something to do when it's inevitably cloudy, because it always is whenever I want to observe something neat. The Zooniverse.org has a ton of citizen science projects, and a large number of them are meant for astronomers. We have the Cataline Sky Survey for minor planets. We have a variation on SETI, Are We Alone in the Universe? We have an active asteroid project where we're examining asteroids for outgassing. Are they related to comets? Maybe yes, maybe no. And we have the Super WASP Variable Star Observing Program, wide-angle search for planets. It's also picking up a lot of variable star information, so that's another project you can get in on. In any case, this is a small selection of the projects available at Zooniverse, and there's an app available for both iOS and Android. So if we don't get clear skies, we can still do some astronomy. And if you've got questions, corrections, I haven't noticed any typos coming through this time, but there always is one. You can contact me at andy.beaton@gmail.com, or on any of the newer social platforms of Mastodon or Blue Sky. And that's what we have. Thanks for your time, and let's have some clear skies.
Thank you very much, Andy. Let's go to questions. Enya, do we have any questions for Andy?
Yes, we do. We have a couple questions, and we have a few interesting comments. So I'm going to combine both of Lewis R's questions together, as they are very related.
Okay.
Question: is there a newer estimation of the number of stars in M22? I haven't checked, but has JWST looked at M22?
Oh, that's an excellent question. The number that I recall reading back when I was in university, and this is a good while ago, is on the order of 500,000 stars. But you're depending on a flawed memory. I wouldn't want to put any money on it. I haven't seen a JWST image of it. It's a good idea. I'm going to go and look for one as soon as we're done here. I'd be fascinated to see how it looks in infrared, and see if there are things showing up there that aren't showing up in the standard visual image. So thank you.
So points that have been brought up in the chat. Eric Briggs discusses whether Dr. Helen Sawyer Hogg spent summer nights at the Newtonian focus of the 74-inch DDO telescope observing M22. Further down in the chat, he mentions that, pardon me, just lost the point. HSH spent the moon dark in June 1939, taking place on Messier 22. It's in her DDO publications.
Excellent. I'm glad to know that. I knew that she had been observing an awful lot of M13, but it would be shocking if she didn't take advantage of M22 as well.
And we have Grace Horvatin, who mentions that in her 8-inch job, she did observe M22 recently.
I have an 8-inch Schmidt-Cassegrain. There it is behind me. And yeah, the stars are uncountable in an 8-inch telescope looking at M22. It's quite spectacular.
And that's all I've got for now.
Okay, thank you very much.
Thank you, Enya. And Andy, I have a question myself for you. You showed a photograph of the Aurora you took from downtown.
I did.
How was it visually?
Visually, not quite as good. It was definitely there. I could see streaks of white that were moving. There was no perception of color for the eyeball that the phone was able to pick up.
Okay, so the camera picked up a little bit more detail than what you could see.
when I was young and observing, the idea of photographing nebula or photographing aurora was ridiculous. It was just not possible. And now everybody can do it with the phone we all carry around in our pockets.
Ah, very good. All right. Thanks again, Andy, for a great presentation.
Thank you.